Okay, good morning, everybody, and welcome back to our human biology classes. And today we're going to proceed with actually beginning to talk about organ systems. So what we've talked about so far, we talked about cells, and then we put cells together into tissues and membranes. Now we're going to start talking about organ systems. And organ systems are systems where we take various tissues and we put the tissues together so to create something which performs a specific function, or sometimes more than one function, but a unit that we would think of as an organ. And today we're going to talk about the largest organ of all, which is the skin, or the integumentary system. That is its proper name, is the integumentary system. It's the skin that actually covers us. Skin is a tremendously important organ. One of the reasons being it is strongly protective, first of all, and it protects the inside of our bodies, which are essentially need to remain sterile. It protects the insides of our bodies from invasion by pathogens and whatever is on the outside. Second of all, it performs all sorts of functions. For example, it is our major cooling mechanism. It is the major way in which we control body temperature is through the skin, through evaporation of sweat from the skin. There are various other functions for skin as well that we'll mention as we go along. So skin is composed of various tissues which are bound together into a thick layer which form the integument, the skin itself. Of course, for human beings currently in our modern times, skin unfortunately has acquired all sorts of metaphoric importance as well. And we pay a lot of attention to skin color. We cannot avoid talking about this if we're talking about the skin. But I want to tell you that as a biologist, the skin color is something which in evolutionary terms, in human evolution, has been, we term it a facile character. That is, it appears and it disappears. It appears and it disappears during human evolution, depending largely on where a group of humans actually reside for a long time. They will develop particular characteristics of the skin, which suit the climate largely that they are living in. For us, this has just assumed in societal terms, has assumed ridiculous proportions. But it behooves us to remember something, and that is that this has not always been the case for human beings. In ancient Greece, in ancient Egypt, in ancient Rome, skin color was a matter of absolutely no importance at all. They would no more think about predicting somebody's character or behavior or anything from their skin color than they would if they were trying to do it for their eye color or their hair color. It would have been a ridiculous concept to those civilizations. It's a relatively modern phenomenon that we've started to attach such importance to skin color. Nonetheless, it has assumed importance. We're not going to talk about all the behavioral stuff and societal stuff. I just want to phrase this in terms of biology for you so that you can actually refer to the biology of this. So here are two gentlemen. And this is a photograph, by the way, by the famous Robert Mapplethorpe. And this gentleman, obviously, of African origin. This gentleman of European origin. Actually, this one rather more than of European origin. He is actually albino, and this gentleman in his skin is producing a lot of the substance melanin. In fact, he's producing a particular kind of melanin, as we'll hear in a while. This gentleman produces no melanin at all. And his skin lacks the pigment in any pigmentation at all. That is not true for most of us. Most of us have one degree or another of pigmentation, and we'll see in a little while how that works. So the integumentary system, the skin, but the skin has associated with it all sorts of other elements, and in particular the hair. Hair is characteristic of all mammals. It is one of the things that makes us a mammal. All mammals have hair. The nails, nails in fact are characteristic of the group of primates to which we belong. Many animals don't have nails, they have claws, which have the same origin, but they are structured slightly differently. Next, the skin has various, embedded in it, has various things. And in particular, there are some various glands that are associated with the skin. And the most important are the sebaceous glands. Sebaceous glands produce oil. They're usually associated with hair. There are a few which are free away from hair, but most are associated with the hair. And lastly, we have sweat glands associated with the skin. And as I've already said, sweat glands are tremendously important because that is our major cooling mechanism. We continuously produce a film of sweat which evaporates. The evaporation of water is actually a complicated physical process, but in order to evaporate water, to turn water from liquid to gas, we have to put in a tremendous amount of heat. That is how sweating works. We sweat, we turn liquid sweat into gaseous water vapor. That takes away a large amount of heat from us, and that is our major cooling mechanism. So here is the structure of the skin, and I will point out to you exactly the things that I need you to remember. The first is to notice that the skin is divided into two major layers. The first layer is this layer here. You see that dark red line there? Pay attention to that, because that's the base of the first layer, which we call the epidermis. Now this, in this diagram, they have called this the stratum. That means the layer basale. That's this here. I want you to change the name. I want you to learn the name stratum germinativum, and I'll show you here. There it is. That's the name I want you to remember. Stratum germinativum. See, you can learn Latin. You don't have to learn much, but you have to learn some of the names. That stratum germinativum is important because this is the layer of cells which is dividing continuously to produce the surface skin cells. So, and there it is. There it forms the basis of the epidermis. Then this layer here, the stratum spinosum. Remember that. This is the layer that causes human beings so much problem, because this is the layer in which the pigments are lodged. These is a relatively thin layer, 5 to 10 cells thick, of living cells, which are produced initially by this stratum germinativum, and they move up almost like a conveyor belt. They're continuously produced, and then move up, stacked up on top of one another. They move up towards the surface. For this layer here, the cells are alive. And then they begin to die. They start dying at this layer here. It says stratum granulosum. You don't need actually to remember that. I only want you to remember stratum germinativum, stratum spinosum, and stratum corneum. Those three layers, that's what I want you to remember, compose the epidermis. So the stratum spinosum, living cells, and they're on their way to the surface, towards the surface. As they go, they get flattened, and they start to have a very strong protein built into them, and that protein is called keratin. and we'll hear about it numerous times. This is a principal protein that is produced by the skin. It toughens those cells, and they actually die, but they remain tied tightly to one another, and they form this layer of dead cells here, which is called the stratum corneum there. These are dead cells, but they're tough, and they form a tough layer over the surface. And that tough layer, first of all, is protective of these delicate living cells underneath, but it is protective not only physically, but it is protective because, first of all, it stops water loss, or it stops evaporation of water from the skin. And it also prevents pathogens from entering. This stratum corneum here continually, when the cells get out here, they actually start to dry out, and they start to flake off, and they flake off that layer. But they are immediately replaced, of course, by cells from underneath. And the skin has a very rich bacterial and fungal flora. It's called the microbiota, and it has a very rich microbiota. It has many, many bacteria, fungi, things living on it. I know you don't want to hear about it, but it is true. That is completely normal, completely natural. One of the ways of controlling the population of bacteria and everything that live on this layer is that these are flaked off. The surface is continually flaked off, and it carries away bacteria and everything with it the whole time. So the overall population is kept low. There are many people, especially microbiologists, who will tell you that our habit of over-hygienic activity may not be very good for us. And one of the things that we do when we scrub our skin continuously with soaps and everything is we scrub this layer off, and we actually make it thinner. And that may not be good. The other thing we do when we do that is we take our normal natural bacteria and everything, and we get rid of them. That may also not be a good thing, because these bacteria, just by being there, they exclude pathogens. So pathogenic organisms can't settle here because the space is already occupied by good bacteria. Bad bacteria can't settle there. And sometimes by overwashing and using disinfectant soaps and everything, we may not, in fact, be doing ourselves any good. That's something to think about. Okay, so we remember stratum germinativum, stratum spinosum, the living pigmented cells, and then the stratum corneum. Some of these other layers here, don't worry about them. They occur in this layer here. This clear layer is especially characteristic of places like the palms of your hands and your feet. It's a specialized layer, so don't worry about it over much. That is the epidermis. The other thing I wanted to point out, this pigmented layer here is extremely thin, very, very, very thin and very delicate. It is very easy to scratch this off, to accidentally scratch it off. And if you just get a scrape or whatever of your skin, you take this off, right? But it will soon heal, and will heal, usually without scarring or anything. It's just to point out this is a very, very thin layer that contains the pigmented cells. The layer below the dermis is much thicker, and this is a layer of a lot of different kinds of cells that are mixed, and they also are mixed with a very tough connective tissue layer that runs all the way through. It has muscle as well, and you'll see from here it's all the way from here on up to there. That is the dermis. At the top, it's folded into, if you have a look here, if we were to peel the epidermis off, this underneath here would be the stratum germinativum. You'll see that this is raised into these lumps called the papillae, the dermal papillae. It increases the surface area for attachment of the epidermis to the dermis. There are very strong proteins holding the epidermis down to the dermis, and it's increased by having these dermal papillae. This is the thick dermis here. The first thing you'll notice is it's richly supplied with blood vessels. When you cut yourself and your skin starts bleeding, what you've done is you cut through to here, and you've cut some of these small blood vessels in your skin. If you cut your skin, usually it's very, very easy to stop it from bleeding, because all you need to do is put pressure on it, close off the cut vessels for long enough. Usually 15 minutes is usually plenty of time. And in that time, remember back to what we talked about, blood vessel, blood corpuscles and everything. We said the platelets. You press on these vessels, you will stop the blood flowing in a little localized area. The platelets will start to release clotting factors, and a clot will form, and the bleeding will stop. That is why first aid, one of the first measures to stop bleeding is to apply pressure. Close the vessels that are cut, and they will begin to form a clot. So it's richly supplied with blood vessels. Those blood vessels up here near the surface break into very, very, very fine capillaries that are not visible. But in the dermis, they are visible as actual vessels, blood vessels running through. They have done something in this diagram. They have colored the arterial vessels red, and they've colored the veins blue. Now this encourages the idea that venous blood is blue and arterial blood is red. It is not. It is not. In actual fact, when you look through your skin, what you actually see most prominently are the veins. If you just look at the back of your hand or look underneath your arm, and you can see the blood vessels, what you see predominantly are the veins, because the veins tend to be much wider than the arteries, and the arteries run deeper. You don't see them as easily. The blood running through your veins is red, but in fact, in order to see them, light has got to go through, bounce off, and be visible again. And when light does that, all the light gets absorbed except blue. And so the veins look blue. Okay, they are red, but all of the redness is absorbed by the skin and everything. So where you see your veins as being blue, that's what gave rise to this myth that venous blood is blue. Venous blood is slightly darker than arterial blood. It is deoxygenated. It's in this, it would be flowing in the veins. It would be flowing in this direction here, back towards the heart. Here, the arteries, it's flowing this way to supply all these tissues with oxygen. So the most prominent things inside the dermis, the most prominent features inside the dermis are, first of all, the hairs. The hairs are extremely complex, and I'll discuss their structure again in a little while. I just want to point out that they also have around the bottom here, they have generative tissue. They have cells there which are dividing to produce the hair. And this here is the hair root or the hair follicle there. You can see the hair protruding through here. So that is the hair, and it's enclosed in the follicle, and the root is down here. Now, most hairs have associated with them glands, which you see here, and these are the sebaceous glands. We'll have some more to say about. All hair also has a muscle associated with it, and that's called an erector muscle. When the muscle contracts, the hair stands up on end. And that is we all know that phenomenon. You hear music that you like, whatever, your hair stands on end. You get a fright, your hair stands on end. That is a hangover from our primate origins. In primates, who are covered, many of them covered with very long hair, the hair is also a signaling mechanism. It signals things to other primates. And raising the hair, for example, is thought not only to signal aggression, but also to make the animal look larger, so that a predator or whatever thinks twice about attacking. And that is the responsibility of this hair, pulls the hair upright. The sebaceous glands produce an oil which moves through the hair follicle and not only lubricates the hair, but comes out onto the skin as well. And that this lubrication here is an important way that the integrity of the stratum corneum is maintained. It is literally oiled by our natural oils. So that's the first major feature. The second major feature is here, and this is a sweat gland. And the dermis is full of these sweat glands. They do tend to accumulate in certain areas of the body, have more than other areas. There are a lot on the face, the palms of the hands, the soles of the feet, armpits, these areas. And it's not surprising either that these areas are also richly supplied with blood vessels, because it is the aim of the sweat glands to act as a cooling mechanism. So the skin is being heated by warm blood, and the sweat evaporates on the surface of those areas and carries away that heat and cools the body down. Then let me just, that's the dermis there, that thick layer. Below the dermis, there is a fat layer. That fat layer varies in thickness. It's called adipose tissue. That means fat tissue. It's a fat layer. It's not only protective of everything underneath. Underneath here lie muscles, the major muscles, then the major organs, of course, and everything else. So this fat layer is actually protective, but in addition, this is actually an insulating layer. It assists us in maintaining body warmth. Most of our warmth is generated in the body core below this, and this acts as an insulator so that we don't lose too much heat. This maintenance of body temperature is a very delicate balance. All of these situations where we have to maintain a balance, for instance, of our body heat, not too hot, not too cold, just at around 37, which is our normal, 37 degrees Celsius, is our normal body temperature. So that maintaining around that level is called homeostasis, keeping things the same, homeostasis. We also have homeostatic systems for maintaining pH, the blood pH, for example. Homeostatic systems maintain our oxygen levels, not too much, not too little, etc., etc. These systems that maintain things in optimal conditions are homeostatic systems, maintaining homeostasis. So there's this layer below, and this is called the hypodermis. That simply means below the dermis. So epidermis, above the dermis, and then the hypodermis is below the dermis. All these layers, by the way, tightly tied together. This is a tough structure, and it has to be. It's protective in all sorts of ways. Okay, so this is just to remind you, stratum germinativum, bottom layer of the epidermis, and it divides to continually give rise to the epidermis. In the epidermis, the stratum spinosum, a thin layer up to 10 cells thick, and this is the layer where pigment cells occur. This is also, by the way, a layer where a lot of immune activity takes place. Our immune system pays strong attention to this layer. It actually sends white blood cells there continuously to survey, because if anything is going to get in from the outside, it's very likely it's going to come in from the skin. As I've shown you, this is very thin. It's very easy to braid this and for things to get entry to the deeper layers of the skin. So there is a lot of immune system activity here in these living cells, as white blood cells, for example, wander around, examining, seeing if fungi, bacteria, or anything are coming in. If they are, the immune system is alerted to respond to it. And then the stratum corneum. Stratum corneum is that dead layer, heavily keratinized cells. They're usually compacted and flat, and they flake off continuously to carry away bacteria, etc., with them. And then below that, the dermis. Okay, so let's talk about melanin for a minute. Melanin is actually what causes darkening of the skin. It's not only gives skin its natural color, but you'll realize that if you're in the sun a lot, as an individual, if you're in the sun a lot, your skin will get darker, and that is because your skin begins to produce more of a species of melanin to darken and protect it. What it is, the melanin is protecting your skin cells against ultraviolet light, especially. Ultraviolet light, the sun produces a tremendous amount of ultraviolet light, and ultraviolet light is extremely damaging. It actually damages the DNA of cells, and you'll realize this layer is very, very thin. It is actually quite easy for light to penetrate through your skin. And if it hits this layer here, ultraviolet light can actually start to damage this layer, which is continually producing cells. It can induce a mutation in these cells, which can be extremely dangerous. And that can lead to tumors, which we'll discuss in a while. So melanin is a protective mechanism, but there's a disadvantage to melanin. If you darken those cells of the stratum spinosum, you actually stop the light from reaching the deeper layers of the skin. And the skin has one very, very important function, and that is it produces a vitamin called vitamin D. And vitamin D is essential. It's essential for all sorts of things, especially for calcium metabolism. This is one of the things that it is particularly involved in. So you have to balance. You need to protect against the sun's UV light, but you don't want to protect so much that you stop producing vitamin D. And this is what has driven the evolution of skin color as human beings have migrated. We all arose in Africa. We arose in tropical regions. And in tropical regions, there is abundant sunlight. And it is the day length is very long. The sun is directly overhead for a lot of the year. So there is intense sunlight. There is no danger of not producing enough vitamin D, but there's tremendous danger that you're going to start suffering from ill effects of constant UV light baking down into the skin. So skin in tropical areas, in populations that are evolving, this is not in individuals who's sun tanning, right? This is a population phenomenon. It's an evolutionary phenomenon. The skin tends to become darker to affect that protection. And at the same time, because it's a tropical area, it's unlikely that people who with those dark skin, with the darkened skin, are going to suffer from vitamin D deficiency. There's abundant sunlight getting through enough to make vitamin D. But human beings didn't stay in Africa. They didn't stay in tropical areas. They migrated. And especially they migrated, for instance, up to Europe, where the sun is seldom directly overhead, and where for a lot of the year, the sun's rays come in at at a shallow angle to the Earth, and where, for example, for a lot of the year, the day length is very short. People in those regions, those populations actually suffered from vitamin D deficiency, and it was advantageous that they stopped producing, that their skin stopped being so heavily melanized, and so they became paler to allow light through in order to make the sufficient vitamin D. They, by the way, certainly still can suffer the damaging effects of ultraviolet light, but the light intensity is much lower, so their likelihood of suffering ill effects of ultraviolet light are reduced. And the need for vitamin D is so great that it is highly advantageous to have a paler skin if you're in a high latitude, if you have evolved in a high latitude. So that is what is climate that actually drives that skin color. Now, there are two kinds of melanin that we produce. One is called pheomelanin, and it's more reddish to yellowish brownish color. That's pheomelanin. And eumelanin. Eumelanin is a distinctly brown to black. Everybody produces both, but European populations of European origin tend to produce much more pheomelanin, this reddish yellowish color. They produce much more pheomelanin than eumelanin, and eumelanin is much more typical of the populations down in tropical areas. So when you suntan, by the way, you tend to build up your predominant melanin. So when we go in suntan, we tend to build up this brownish pheomelanin to darken our skins. Suntanning is entirely different to the development of racial pigmentation. And when I say racial, I mean a biologically racial pigmentation. That suntanning is a temporary response to damaging your skin with sunlight. The skin color is actually a population characteristic, and it reflects the evolutionary origins of the population that you belong to. So here's another thing. The genetics of skin color are very interesting. There's many genes that govern skin color. And here, these two beautiful ladies are actually sisters. They're actually twin sisters. They're obviously not identical twins, but you can see. I think, if I remember rightly, it was a European mother, like Swedish or something, and then the father, I believe, was Caribbean. And you can see that there's a tremendous genetic variability even in these two fraternal twins governing their skin color and their characteristics of the hair and everything, which is part of the skin. So there's a lot of genetic determinants of skin color and the characteristics of the hair and nails and everything else that the skin produces. So one of the things to point out is that this adoption of these skin colors is not just, well, you're either this or you're that. In fact, it comes and goes in human populations rapidly. As I said before, in biological terms, we say that this is a facile characteristic. So, for example, human beings migrated from Africa north to Europe. Maybe the populations had developed paler skins, but those populations didn't stay where they were. They migrated. They migrated east and west, and they went down again. They went down back into tropical areas. What happened when they went back down? The populations had pale skins in the north, and then as they came back down again, they redeveloped dark skins. We see this change taking place very, very rapidly in human populations over a period of, of thousands of years. These racial skin color characteristics tend to arise. So if we look here, this is only a very, there's a very large diagram of all, the whole range of skin colors that human beings show. I can't quite remember where everybody is from. They have matched them to Pantone standard color. Pantone colors, these are standard colors on a standardized color scale. So we look at them all, this whole range of colors. They're all from pale pink to deep browns, etc., because it is the pheomelanin and eumelanin balance that is giving the skin color. This gentleman here is a Pacific Islander. The populations that gave rise to the Pacific Islands went up through Europe, east, and then down, all the way down to Borneo, etc., etc. And so those populations in their migrations over tens of thousands of years, which started off dark, went pale, went across, the skin got darker again and darker again, and now is commonly quite dark in Pacific Islanders. This lady is from Ireland, and she's a typical Celtic look, very pale, with reddish cheeks, often a reddish nose. It's very typical for Celts, and very often in Celtic peoples. Her hair is white, but it's quite probable that her hair was red. That is quite typical. This chap, I don't remember where he was from. This little child is also a European Celt from somewhere with a reddish hair, very pale skin. Hispanic lady, probably Southern Mediterranean. Again, Southern Mediterranean populations tend to have this olive-colored skin, which is darker. This gentleman from Africa with a very dark skin, again, probably those people that his ethnic group is derived from, probably from equatorial or tropical Africa. This is Asian. Some Asian populations. The Asian populations vary tremendously depending on what latitude they are in. They go all the way from very pale in the north to very, very dark in Southern Asia. This lady, I think, is from Finland or somewhere like that. Again, pale skin with reddish hair. This lady, I'm not sure where she's from, but she may be mixed race of maybe African European mix or something like that. I'm not entirely sure, but it just gives you an idea of the range of skin color. And as I say, you can find in National Geographic, a search in the National Geographic website, and you'll look up the issue on race, and there's a huge diagram with many different colors that human beings have, all reflective of climatic conditions in the places where they originated. So back to the skin, we're going to talk a little bit about hair and about sweat glands. So here, this is a hair, and again, it sits in a follicle of this envelope inside the dermis and the epidermis. It consists of a hair shaft. At the bottom, there is an area called the hair papilla. And the hair papilla is what generates the hair. This is very like the stratum germinativum. In fact, it's modified. You can see how this folds. There's the stratum germinativum. It folds all the way down here, and it's modified to specialized to produce the hair. Hair is actually cells. It is rather like the stratum corneum. It's dead cells that are packed very tightly together and tightly bound with this protein called keratin. That's the major component of the hair shaft. The hair is dead cells, except for the very bottom here, where the hair is being generated. And a hair follicle like this will generate that hair. It will carry on growing that hair for a number of years. It depends on where it is, but months to years, it will carry on growing the hair. And then very often at the end of it, the follicle stops producing the hair cells continuously, and the hair dies and falls out and is often replaced with a fine hair called a down hair. So this is a normal brisk hair. So this at the bottom is called the hair bulb or the hair root there. And there are various layers to the hair we don't have to worry about. It has a middle kind of layer of cells called the medulla, and then cortex, and then the outside is the cuticle. So that's the hair. It is only supplied with blood at the bottom there, and the hair papilla. And here is the muscle, called the erector muscle, and that is the muscle which is responsible for erecting the hair. That takes place under the control of that part of the nervous system, over which we have no control. This is an unconscious response will actually make the hairs stand on end. Okay, so a modification of that whole system are the nails. So here is a nail. This is the last joint of the finger or of the toes. Here's the last joint there, the bone. Don't worry about the names. That's the joint there. And obviously the rest of the finger here. But here's the skin. So there's stratum germinativum right underneath there. Then it folds underneath here to form a root, a nail bed underneath there. And that nail bed is still the same germinative cells. It's cells rapidly dividing, and they produce, rather like the hair, they pack dead cells together very, very tightly and tie them together, weld them together with keratin. And they do it continuously to produce the nail. So the nail grows continuously from here. There is a portion here where the attachment of the nail is a little bit tighter to the underneath, and that gives us that half moon at the bottom of the nail bed. Then it remains attached here, but it moves. The nail is able to slide over the nail bed. Although, as you'll know, if you've ever lifted a nail, it is attached, and lifting the nail is tremendously painful. So that's the nail there. As I say, this is characteristic of primates, the group of mammals that we belong to. But in other mammals, this may be modified to produce a claw. And a claw has a much more round, three-dimensional shape, not this flat shape that a nail does. There are useful tips for you. First of all, our nails are to protect this part of our finger. There are many, 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 many nerve endings here in your nerve, the end of your finger. Let me just go back here for a minute and point out something to you about the dermis. The dermis is also a place where there are many nerve endings which are relaying a lot of sensory information. They register heat, pressure, pain. All of these things are registered by nerve endings which are embedded into the dermis. And these become extremely concentrated, for instance, at the fingertips. Our fingertips are exquisitely sensitive, especially to pressure. You feel very, very small objects with your fingertips. That is a huge advantage because we use our fingers the whole time. We actually, in a way, see parts of our environment with our fingers. And because this is so densely filled with nerve endings, it needs to be carefully shielded and protected and that is the function of the nail. Of course, sometimes, we have an accident, bang our nail. This is also very richly supplied with blood vessels. And if you bang your nail, you get that terribly painful condition where you start to develop a blood blister underneath your nail. And the pain is because the blood is swelling up against all of these pain receptors and in your nail, in the end of your finger. A little tip for you, if ever that happens, if you blacken a nail, take a very, very, very fine drill, sterilize it, and don't press, just gently rest the drill on your nail, turn the drill and drill a hole through, and let the blood blister bleed. It relieves the pressure, and it's miraculous. Takes away the pain instantaneously. Be very careful though, dress it with an antibiotic ointment or something, and keep it open. It may close up as the blood clots. You can open it again to allow it to drain, and this will heal much quicker. You may even keep the nail. If you get an extensive blood blister here under a nail through accident, you often lose the nail. But it's not a problem because a new nail grows. Over a period of months, the new nail will grow. Okay, nails can go wrong. Skin can go wrong. It is subject to disease. The commonest disease of nails is actually within the feet. And this is a nail fungus. This nail just looks, it's a bit deformed and mishappen, but it's the strange yellow color, and it is actually not nearly as strong. The nail tends to break and flake very easily. This is because this nail, the nail bed and the nail itself are infected with a fungus. This here is a worse condition. It's not actually that common to see fingernails get infected with these fungi and things. This is a yeast. Yeast is a single-celled fungus. And this person has a yeast infection of the fingernails. But I suspect that this person probably has an immunodeficiency of some sort. This is not a common situation. So something's wrong with their immune system, probably. This is very common to have this fungal infection of the nails. And it is curable. There are various things that you can do, but often you require to really treat it properly if it's persistent. There are topical things, there are ointments and things you can put on to deal with it, but it is often difficult to deal with the infection in the nail bed. It's hard to kill off that fungus in the nail bed. Sometimes you require systemic treatment. You require an antifungal by mouth to circulate it in the blood to get rid of it, but it is eminently curable. So let me just point out the other two glands that we need to talk about. First of all, these here are the sweat glands, and then the sebaceous glands. Sweat glands producing sweat, and not only do they produce a solution of salt. There are various things in sweat, and for example, there may be some antibacterial compounds in the sweat. The salt in sweat is also antibacterial. It makes this very hostile. The sweat evaporates and you precipitate salt onto your skin. It makes it a very hostile environment for microorganisms to live. So sweat has several different functions. You sweat in response to body temperature. The body in the brain registers temperature, and then if your temperature rises, hormones are sent throughout the body, and one of the things they do is, if your body temperature is rising, they instruct your sweat glands to produce more sweat. There's a body down here. This is where the sweat is actually produced in the gland. Then there's a duct to the surface and a pore through which the sweat emerges. You've probably seen on a hot day, you'll see some beads of sweat building up at the mouth of the sweat glands there. The sebaceous glands just produce a lipid which lubricates the hair. It also assists in keeping the hair free of bacteria. It continually moves up through the follicle and also lubricates the stratum corneum. It produces lipids, oils. So that also, under normal circumstances, it just flows freely. But this is a situation we're all familiar with, and that is that every now and again, one of these hair follicles goes wrong, and we actually find that, for example, we block up a hair follicle, and we end up developing pus underneath it, and it ends up as a pimple. When this happens broadly across the skin, or commonly across the skin, we call it acne. And that's, you know, for most people is a relatively temporary situation during puberty in particular. This is common, and it's a response to hormonal changes. We don't exactly understand why, but the sebaceous glands begin to produce abundant oils, and the oils actually evaporate. They solidify at around the hair and block the hair follicle, and the lipids start to accumulate underneath, and bacterial activity begins, and you end up with what is essentially a little tiny abscess. So for most people, this is just a matter of a couple of years when they have to worry about acne, and then it fades away. But it can last for a very long time. Some people, unfortunately, have lifelong problems with acne. There are different degrees of acne as well. This is just ordinary mild acne, and won't produce scarring or anything else. But in some cases, a condition called bullous acne develops, or cystic acne, where instead of just a small pimple like this, a huge area of inflammation develops underneath the skin, which forms distinct lumps. And that is, it's not a dangerous situation, but it can lead to scarring, which can be very prominent. The risk factors for acne are youth, hormones, but testosterone and estrogen. So this is particularly associated with puberty, when a lot of these hormones are released. And then definitely there are certain bacteria which are specifically associated with acne. And one of them is this Propionibacterium acnes, is commonly isolated from these pustules. There are some other bacteria which may also be involved. And then the last thing is that genetics very strongly involved. This tends to run in families, share a propensity for acne. Absolutely no risk factor, despite what everybody tells you. Diet has no impact. Eating chocolate is not going to do it. Okay, eating unhealthily, and eating unhealthily does all sorts of things to you, but it does not cause acne. The other thing is, people say, oh, he's got acne because he doesn't clean his skin, he doesn't wash his skin. Absolutely not. It has nothing to do with it whatsoever. It has nothing to do with it whatsoever. And in fact, over cleansing of the skin may make it worse, and may increase the likelihood that you develop acne. Some other diseases for you, just to finish off your day. A very common condition are fungal infections of the skin, but they tend to occur in creases and in areas of high skin moisture and high humidity. So, for example, in these folds underneath the toes, this is a fungal disease called athlete's foot, which is probably familiar to many of you, and no, you did not get it from the gym showers. We probably all carry this fungus as a normal part of our microbiota. But under normal circumstances, it does not cause a problem. There are just certain, we don't always understand the reasons why. All of a sudden it starts to take over. And what it's doing is the fungus is growing underneath and through, especially the stratum corneum, even down to the stratum spinosum. And it grows through, it breaks down the keratin, it breaks down those dead cells, and those dead cells start to flake off and cause these lesions to appear. And this weakens underneath. You may even crack through here underneath. Now it's lost this protective, strong stratum corneum. It may break through here and crack and bleed, or be, in any case, be painful. This is another very closely related condition. This is called jock itch. This is in the groin, but very often extends from the groin and the inner thighs all the way up in between the buttocks. This is also a fungal infection, and often is very, very, very irritating, very annoying, painful, and itching, and very typical of hot, humid times of the year. So this appears to be associated with you. Here's the fungus here, actually. And these are the fungal cells extending all the way through. These are fruiting bodies that are of the fungus. And it extends like a net through the stratum corneum, breaking it down and causing this irritation underneath. It's your immune system reacting very strongly to the presence of the fungus and causing this inflammation and pain. But fortunately, these things are easily dealt with, even just over the counter. Things like this, Lotrimin or whatever. These work usually very well. You just have to be very careful, but you do it for a long time. Make sure that you've killed off the infection completely before you stop, and be ready to do it again, because these things are often resident in our skin, as I've told you. They flare up for unknown reasons. The last thing that I want to tell you about are the skin cancers. There are two groups of cancer that we need to talk about. The first are the basal and squamous cell carcinomas. These are largely they are not benign cancers, but they are very slow growing, and they're not particularly invasive. And they just tend to be unsightly and to break down the skin. In areas you'll see where there has been a lot of sun damage to the skin. And they are relatively easily cured. They are treated with liquid nitrogen, for example. If need be, if they're very deep, then surgery. They can be cut out. Sometimes they use chemotherapy, and if it's very resistant, then they may even use radiation, but that's not common. But they do respond very well to radiation treatment. Again, these are usually not particularly dangerous, although they may be, if they're left, they may become extremely unsightly, and they may actually destroy so much tissue that you may have to have extensive plastic surgery to repair the damage. But this one here is extremely dangerous, and this is something you should all be aware of. This is melanoma. Melanoma is a very aggressive, highly invasive skin cancer, also associated with exposure to sunlight, but there are other risk factors for melanoma as well. And it definitely more common in people with pale skins, either Caucasian or just anybody with a pale skin is more at risk. Melanin definitely seems to afford a protection against melanoma. But even in people with very dark skins, need to be really careful, because there are areas of the body where melanoma, in African Americans, for example, melanoma sometimes occurs in the nail beds, on the whites of the eyes, on the palms of the feet. In these kind of areas where there is pale skin, melanoma may in fact develop, although it's not nearly as common as it is in Caucasians. it can just arise spontaneously. It doesn't have to be associated with sun. It can just arise spontaneously as well. They're characteristically, the mole is mottled in some fashion, and it has irregular borders. And I'll show, this is for your information, remember this, but for your information, to learn to begin to distinguish between normal moles. Everybody has moles. They are just slight aberrations of the development of the skin cells. Everybody has pigmented moles and non-pigmented moles as well. But a normal mole usually has a very distinct border. They tend to have a relatively uniform color. And they don't usually reach a very large size. So first of all, this normal mole, but have a look at this. This is melanoma. The first thing to notice is asymmetrical. And that's second. This is a normal mole with a clear border. This is a melanoma. It has an indistinct border. In fact, often the border seems to disappear. Third, look at the color. Normal moles tend to be relatively uniform in color, but melanomas tend to vary in color. And they can go from very, very dark to very, very pale in the same mole. Diameter, normal moles are usually relatively small. If you have a mole which is larger than the diameter of a pencil eraser, you need to have it checked. Not to say that it is a melanoma, but melanomas tend to get a larger size relatively quickly. Any mole that appears suddenly, any of these moles which suddenly change character or change color, suddenly start growing, change their borders, these need to be checked immediately. Melanoma is extremely dangerous, very, very invasive, and extremely difficult to treat. So, okay, so that is it for today. And I hope that this was not only interesting, but useful. And I hope that you are able to follow along with these classes easily. I'll see you again tomorrow, Friday. I apologize that this is a day late, but I'll see you again tomorrow. Thank you.